Have you had a cold, the flu, COVID, or any other infectious disease? Did you wish you knew how you got it? Would you like to trace its spread through your friend group and your entire school? Today I'm going to tell you about how we use a tool called viral genome sequencing to trace and learn from disease outbreaks.
Imagine everyone on the bus gets a cold. Maybe that's happened to you. It's happened to me. One day, Alex got on the bus and sneezed the whole time. Alex likes to gossip on the bus, and when they weren't gossiping, they were sneezing. Alex sits next to PJ. 2 days later, PJ was sneezing, and so was Philip. Then Andy, Crystal, Corey, and Aaron's were sick. Corey sneezed a bunch into his hand and then touched the entire bus. Wow, Corey. Later that week, you got sick, and so did a bunch of other people, and then a bunch more people after that. You're pretty sure you got it from Corey, but before you make up your mind, you want to know for sure. At this point, everyone on the bus is sick. Everyone agrees to swab their noses so that you can put their nose swabs through a process called genome sequencing. You might already know that you have a special code called your genome, made of DNA, that is unique to you. DNA is like words, written with the letters A, T, C, and G, and genome sequencing reads the words that make up your genome. It doesn't tell us what the words mean, it just reads the letters. Viruses have genomes too. Viruses are a lot less complicated than we are, and they copy themselves really fast inside your body, so their genomes are a lot smaller than ours. But because they copy themselves really fast, they make a lot of mistakes. We can use those mistakes to trace the virus's movement from person to person. The process is simple. It's like a game of telephone. Imagine you learn a new TikTok dance, and when you learn it, you make a mistake. That mistake is called a mutation. You teach your friends, but when you teach them, you teach it with the mutation. They make their own mutation, and then they teach their friends, and they teach them with both their mutation and yours. And the dance spreads, everyone adding their own mutations. We can use these mistakes to build a family tree of bad TikTok dances. You can build a family tree of viruses in the same way. When the virus copies itself in your body, it makes mistakes, or mutations, when it copies its genome. The virus you spread to other people contains those mutations. Then, when those people spread their own copies of the virus, they spread your mutations and their own new mutations too. The next generations of infections adds another round of mutations, and so on. Back to the bus. We use genome sequencing to read the genomes of the viruses in everyone's nose swab. The first thing we find out is what virus everyone had. Almost everyone had rhinovirus, one of the viruses that causes the cluster of symptoms we refer to as the common cold. The only exception is Alex, the first person who showed up sneezing. Alex had a different virus, SARS-CoV-2, the virus that causes COVID. So even though their symptoms showed up first, they couldn't have possibly started this outbreak. Next, we reconstruct the family tree from everyone else's viruses. Let's replay. Alex got on the bus and sneezed the whole time. They have COVID. But Alex wore a mask and avoided touching anything, so Alex doesn't actually infect anyone else on the bus. 2 days later, PJ was sneezing, and so was Philip. Both of them had separately gotten rhinovirus outside the bus. Then Andy, Crystal, Corey, and Aaron's were sick. Half of them had gotten rhinovirus from PJ, and half got rhinovirus from Philip. Corey sneezed into his hand and then touched the entire bus. Corey caused what we call a super spreader event. Later that week, you got sick, and so did a bunch of other people. All of you got rhinovirus from Corey. Then, the rest of the bus got it. Every person infected more than one other person. This means that the virus will continue to spread, and when it reaches the school, it will spread through the school and to students and teachers' families, to the places where parents work, and to their families, and so on. In my work, we do this process for outbreaks of different viruses, sometimes for the entirety of Massachusetts. When it comes to SARS-CoV-2, the virus that causes COVID, we use the snot from your COVID test that is left over after you get your test result. We don't know your name or anything about you, but we can sequence your and other people's SARS-CoV-2 virus's genomes and recreate the family tree of an outbreak. On the left, you are looking at a huge family tree of SARS-CoV-2 viruses. On the right, we are adding city information to the family tree, allowing us to watch SARS-CoV-2 move from city to city. We work with the Department of Public Health to anonymously connect each nose swab to information like symptoms and whether or not people were vaccinated. For an outbreak of the SARS-CoV-2 Delta variant in Provincetown, Massachusetts, we used the viral genomes to trace the spread of the outbreak, then worked with the Department of Public Health to say which genomes came from people who were vaccinated. Here's what that data looked like. The dots represent people we got viral genomes from, and the arrows represent spread from person to person that we were able to detect from the genomes. The red dots are people who were vaccinated. We saw that people who were vaccinated were spreading COVID, which meant that masking was still very important for decreasing spread of the virus. Getting vaccinated is still important because even though you can still spread the virus, other research has shown that when you're vaccinated, you spend less time contagious, so you have less of a chance to spread the virus. Most importantly, getting vaccinated dramatically decreases your chance of getting very sick, dying, or experiencing long-term effects. We can do this for other viruses too. Combining spread detected from the genomes with information like city, age, symptoms, vaccination, or behavior could allow us to learn about whether the virus is spreading through snot, poop, the air, or something else, what groups of people are most vulnerable to catching the infection, and whether or not vaccines are decreasing infection and spread. This information can be used to make recommendations about vaccination, including boosters, and about whether or not other tools like hand washing and masks are needed to prevent spread.
All of this together can help keep communities healthy and save lives.